Good morning. In the last class you had seen the topic capacitors. Now you know about what is capacitance of a capacitor, what is the expression for finding out the capacitance of a parallel plate capacitor. Today we are continuing that topic by finding out the capacitance of a capacitor. The capacitance of different capacitors like a spherical capacitor, a cylindrical capacitor, and also a parallel plate capacitor having dielectric slab in between the plates. So first we are going to find out the capacitance of a spherical capacitor with the outer sphere earthed. Here you can see A and B are the two concentric metal spheres. A is having radius small a and B is having radius small b. And the gap between them is filled with air. So air is the intervening medium between the spheres A and B. The outer sphere B is earthed. Now we are giving a charge plus Q to the inner sphere A. So we are giving a charge plus Q to the inner sphere. So what happens? Equal and opposite charge, that is minus Q, will be induced on the inner surface of the outer sphere. See, we have given plus Q charge to the sphere A, and you can see that due to this charge, opposite charge, equal amount of opposite charge will get induced on the inner surface of the outer sphere B. So now the induced charge on the inner surface of the outer sphere is minus Q. O is the center of the spheres. We are considering a point capital P which is at a distance small r from O, and we are going to find out the capacitance of a spherical capacitor. You know how to calculate the capacitance. Capacitance C is equal to Q by V. So first of all we are going to find out V. That is the potential difference between the spheres A and B. So we consider the point P which is at a distance r from the center O. So what is the expression for the electric field at P? So electric field is given by E is equal to, vector E is equal to 1 by 4 pi epsilon 0 Q by R square into R cap. Where R cap is the unit vector which is acting along OP. That means you can see the direction of electric field there which is radially outwards. So that is expression for electric field, that is 1 by 4 pi epsilon 0 Q by R square into R cap. Now we know the expression for finding out the potential difference between the spheres, that is V, which is equal to minus of integral E dot dl. So we got E. Now what is dl? dl is the displacement vector along a path from B to A. dl is the displacement vector along a path from B to A. So what will be E dot dl? We know that the expression for finding out the potential difference V is equal to minus of integral E dot dl. The outer sphere is having the radius B and the inner sphere is having radius A, isn't it? So the integral limits are from B to A. We are moving from B to A, outer sphere to inner sphere. So the dl is having direction from B to A and E is having direction radially outwards. So E is radially outwards and dl is, you can see dl is acting inwards. So E and dl in opposite direction. So E dot dl is E dl cos 180, which is equal to minus E dl itself. Now, in moving a distance dl in the direction of motion, we are moving in the direction of r decreasing. That means we know that r direction of r is E is radially outwards. So that r cap is the unit vector along OP from A to B. Now we know that dl is having direction from B to A. So we can replace dl with minus dr. Since a distance, in moving a distance dl in the direction of motion, we are moving in the direction of r decreasing. So that dl is equal to minus dr. So substituting here dl is equal to minus dr, but we will get E dot dl will be E dr itself. So our expression for potential will become minus integral B to A E dr. Now we know the expression for E, that is 1 by 4 pi epsilon 0 q by r square, and dr is there. Taking the constants outside, integrate between the limits a to b, 1 by r square dr. So integrate it, give the upper limit and lower limit. You will get the expression as q by 4 pi epsilon 0 into 1 by a minus 1 by b. That is, taking the LCM, you can see that it is q by 4 pi epsilon 0 into b minus a by ab. So we got the expression for V. Now what is capacitance? Capacitance is given by Q by V. So divide Q with the V we got. So Q divided by Q by 4 pi epsilon 0 B minus A by AB. Cancelling Q, we will get the capacitance of a spherical capacitor as 1 by 4 pi epsilon 0 AB by B minus A. Or this can be also be written as 1 by 4 pi epsilon 0, 4 pi epsilon 0 divided by 1 by A minus 1 by B. Without taking the LCM, you can write it as 1 by A minus 1 by B itself. See what happens when B is equal to infinity. When B is equal to infinity, 1 by B will become 0. So the denominator contains only one term, that is 1 by A. 1 by A will become A to the numerator. So it will be 4 pi epsilon 0 A. So that is the capacitance. We considered B as infinity. B is the radius of the outer sphere. So the radius of the outer sphere is considered as infinity, means we had found out the capacitance of an isolated conducting sphere of radius A. Initially we had found two metal spheres, considered two metal spheres as a spherical capacitor, and we got the expression for capacitance as 4 pi epsilon 0 divided by 1 by A minus 1 by B. Now we are giving a condition that if B is equal to infinity, what happens? If B equal to infinity, think that what about the picture? The outer sphere is not there, isn't it? Outer sphere, the radius is infinity, means there is only that inner sphere exists. Inner sphere can be considered as an isolated conducting sphere of radius A. So the capacitance will be 4 pi epsilon 0 A. That is the capacitance of an isolated conducting sphere of radius A. Now we are again considering the capacitance of the spherical capacitor, but the inner sphere is earthed. Again you can see two concentric metal spheres A and B of radius small a and small b respectively. And we are giving a charge plus q to the outer sphere B. So plus q charge is given to the outer sphere B. Now this plus q charge, it is distributed on its inner as well as the outer surface. So the inner surface of B will contain plus q1 charge and the outer surface will contain plus q2 charge. So that q1 plus q2 is q itself. That means the given charge q is distributed among the inner surface of B and also on the outer surface of the B with the amounts q1 and q2 respectively. Now on the inner surface of B there is charge plus q1. So this plus q1, due to the presence of this charge, an equal and opposite charge is induced on the outer surface of A, that is minus q1 is induced, and it is called a bound charge because this charge is induced due to the presence of other charge, that is plus q1. So minus q1 is the induced charge or bound charge on the outer surface of A. Again, what happens to the inner surface of A? Due to minus q1 on the outer surface, the inner surface will have plus q1. But the charge plus q1 on the inner surface of A being free leaks to the earth, since it is earthed. Since it is earth, the inner charge gets leaked to the earth. But minus q1 on the outer surface is not leaked because it is induced charge or bound charge. So here we can consider the two spheres now behave as two capacitors which are connected in parallel. The first one is the inner sphere of radius A and the inner surface of the outer sphere. See, here you can see on the A there is minus q1 and on the B there is plus Q1. So minus Q1 and plus Q1 equal and opposite charges separated by a particular distance, that forms a capacitor. So the inner sphere of radius A and the inner surface of the outer sphere form a capacitor. Now what about the next capacitor, that is the outer surface of B. See the outer surface of B and the earth form another capacitor. So both capacitors are of spherical form, and we know the expression for the spherical capacitance. So we can substitute we can find out both the capacitance values C1 and C2, and since they are connected in parallel, we can find out the total capacitance by simply adding C1 and C2. So let's find out what is the first capacitance, C1. C1 means the inner sphere of radius A and the inner surface of outer sphere, that forms a spherical capacitor having capacitance C1 is equal to 4 pi epsilon 0 AB by B minus A. Now the second capacitor is the outer surface of B and the earth. Earth, here we can consider it as to be an infinity case. So what happens? The capacitance is simply 4 pi epsilon 0 B. So C2 will be 4 pi epsilon 0 B. Now since these capacitors are in parallel, you can add that and can find out the effective capacitance of this combination as 4 pi epsilon 0 B square by B minus A. So that is the expression for the capacitance of a spherical capacitor with inner sphere earthed. Next, the capacitance of a cylindrical capacitor. So here we are having a cylindrical capacitor formed by two coaxial cylinders, A of radius small a and B with radius small b, and each coaxial cylinder is having length L. Now air is the medium between A and B. Here also the outer cylinder B is earthed. We are giving a charge plus Q to the inner cylinder. So the inner cylinder now have a charge plus Q. So an equal charge minus Q will be induced on the inner surface of the outer cylinder, and a charge plus Q will be induced on the outer surface of the outer cylinder. I repeat, we are giving a charge plus Q to the inner cylinder. That means equal amount of charge, equal but opposite amount. That means minus Q will be induced on the inner surface of the outer cylinder and plus Q on the outer surface of the outer cylinder. Now we know that the outer cylinder is earthed. That means the charge plus Q induced on the outer surface of the outer cylinder flows to the earth. Here also we are considering a point P which is at a distance R, and we are going to find out the electric field at that point, and we are going to find out dl, so that we will get E dot dl, and integrating that you will get a potential difference V. From that we can find out the capacitance by the equation C is equal to Q by V. So considering the point P at a distance R from the center O, what is the electric field? You have to study the expression for the electric field at a point in the space between the two cylinders at a distance r from the axis as 1 by 2 pi epsilon 0 L Q by R. So you have to by heart this equation, that is the electric field at a point in the space between two cylinders is given by 1 by 2 pi epsilon 0 L Q by R. Now what is the expression for potential V is equal to minus integral B to A E dot dl. Again we can see that dl is the displacement vector which is along a path from B to A. Now we can see that E is radially outward and dl is inward. Therefore, E dot dl will be E dl cos 180, which is equal to minus E dl. Again, we can take that we are moving in the direction of decreasing R, so that dl is equal to minus dr. So, E dot dl will be E dr itself, and you can substitute again for V. Then you know the expression of E and integrate it within the limits B to A. So you will get the expression as Q by 2 pi epsilon 0 L log B by A. Now that is expression for V, isn't it? Potential difference between the cylinders A and B. Now you have to find out the capacitance. So capacitance is equal to Q by V. So what happens? That Q gets cancelled and you will get 2 pi epsilon 0 L divided by log B by A. So this is the capacitance of a cylindrical capacitor having length L with the inner radius A and out with the inner cylinder having radius A and outer cylinder having radius B. Now you can see some practical examples of this cylindrical capacitor, like a coaxial cable. Coaxial cable consists of a cylindrical metal sheet with a coaxial central conductor between which the medium will be dielectric. Just to know that one of the practical applications of the cylindrical capacitor, that is coaxial cable. And another example is a submarine cable. Now the next topic, effect of a dielectric medium. We know that if C is the capacitance of a capacitor with air or vacuum as the medium, and C dash its capacitance with the dielectric, then C dash by C is equal to epsilon R, where epsilon R is called the relative permittivity of the medium. And Faraday found that this capacitance of a capacitor increases if a dielectric is placed between the plates. See, think that we are having a capacitor with air as medium. So the capacitance is to C. Now we are replacing that air with a dielectric medium. So what will happen to the capacitance? That is given by the equation C dash is equal to C into epsilon R. So C got multiplied with epsilon R That is the relative permittivity of the medium. That means C dash is equal to C into epsilon R means the capacitance C dash is increased. So when we replace the air or vacuum with a dielectric medium, the capacitance of that capacitor increases. And our last topic, the capacitance of a parallel plate capacitor, which is partly filled with a dielectric slab. We had already studied the capacitance of a parallel plate capacitor with air as medium, isn't it? Where the capacitance is given by C is equal to epsilon 0 A by D. If that air is fully covered with a dielectric medium, what will be the capacitance? Epsilon R into C, that is epsilon 0 epsilon R A by D will be the new capacitance if the entire space between the plates of the capacitor is replaced with a dielectric. Now we are going to find out the capacitance of a parallel plate capacitor partly filled with a dielectric slab. So here you can see two plates P and Q separated by a distance D, and in between these plates a dielectric slab of thickness T is introduced, and the remaining portion is obviously air will be the remaining medium. So T is the thickness of the dielectric slab and D minus T will be the thickness of the air. Now we are going to find out the capacitance. So what is the electric field at any point in the air space between the plates? We had found out the expression for the electric field due to a parallel plates in the topic applications of Gauss law, isn't it? So where we found out that the electric field at any point between the plates is given by E, which is equal to sigma by epsilon 0. So in between the plates where there is air, the electric field is equal to sigma by epsilon 0. Now in between the plates there is dielectric slab, isn't it? So what is the electric field at any point in the dielectric slab? It is E dash given by sigma by epsilon R into epsilon 0. Obviously multiplied with that equation. Multiply epsilon 0 with epsilon R. So we will get the electric field at any point in the dielectric slab. So now we are going to find out V. What the potential difference between the plates. So we know that V is equal to E into D. So in the case of air medium, the electric field is E and the air is of the length D minus T. So E into D minus T plus E dash, that is electric field in the dielectric slab, into thickness of the slab, that is T. Now substituting E as sigma by epsilon 0 and E dash as a sigma by epsilon 0 into epsilon R, and taking the common term, you will get V as a sigma by epsilon 0 into D minus T plus T by epsilon R. So that is the expression for V. From that you can calculate capacitance as Q by V, where Q is equal to sigma A. So cancelling sigma, you will get capacitance as epsilon 0 A divided by D minus T plus T by epsilon R. How can you compare this capacitance with that of an air capacitor? An air capacitor has a capacitance C is equal to epsilon 0 A by D, isn't it? So to compare it with that, just divide the numerator and denominator of this equation with D. So what you will get? Epsilon 0 A by D divided by 1 minus T by D plus T by epsilon R into D. So we know that epsilon 0 A by D is the capacitance when the medium is air. So it is divided by another term which is less than 1. That means C is greater than the air capacitance. That means on introducing dielectric material between the plates of a capacitor, the capacitance increases. So we had seen in today's class capacitance of a spherical plate capacitor with outer sphere earthed and inner sphere earthed. Then capacitance of a cylindrical capacitor. Effect of dielectric, that means capacitance increases when we replace the air with a dielectric medium found out by Faraday. Then capacitance of a parallel plate capacitor which is partly filled with a dielectric slab. If it is fully filled with a dielectric slab, what is the expression for capacitance? It is epsilon 0 epsilon r A by D. With air as medium, it is epsilon 0 A by D. With a dielectric medium, epsilon 0 epsilon r A by D. If it is partly filled with a dielectric slab, the expression is epsilon 0 A divided by D minus T plus T by epsilon r. Thank you.